Hi, welcome everyone. This is Machine Learning with Python session 2 on the descriptive analytics. As previously covered, we have covered in session 1 the introduction to machine learning and 1.1 introduction to Python and the libraries. So uh, this is going to be at least 10 sessions approximate. Could be less or one more, but around that, and should be covered by the end of this month or beginning first week of June. It should be completed. With that, we have Jaimit Wasawa and Yogesh Jagtap have joined, and we will be asking Jaimit to lead as the study circle lead for machine learning with Python session 2. I hand over to Jaimit Wasawa, who has been doing excellent job. Go ahead, Jamie, take over from here. Thank you.
Yeah. So thanks for the introduction. So welcome everyone for Machine Learning with Python session 2 on descriptive analysis. So before we start, what are the objectives first that will be covered in this session, which is to understand the concept of descriptive analysis, learn to load structured data onto DataFrame and perform exploratory data analysis, learn data preparation activities of filtering, grouping, ordering, and joining the data sets. Then learn to handle data with missing values, learn to prepare plots such as bar plots, histograms, distribution plot. In a way, representation of data for different kind of analysis and comparisons. Visual representation. So let's get started. So what is descriptive analysis? So it's a comprehension of data using data summarization, basic statistical measures, and visualization. So data has been used by many. If in the present context, data scientists have been using it, structured data with the concept of SQL or structured query language, where the SQL tables or structured query language tables represent data in terms of rows and columns and make it convenient to explore and apply transformations. So similar kind of concept exists within Python through data frames, which gives us which is invoked from Pandas library. So it's a two-dimensional data structure. Uh, it is a flat in structure, and it is arranged in rows and columns. And rows and columns can be indexed or named, just how we do it in SQL or structured query language. So after that, data and how we work with them. So what is data? The facts and statistics collected together for reference or analysis. And the way we can work with them, or we can represent the data. You can see the various list of things, which is a tabular format, which is a table format that we just discussed about. Then graphs, for visual representation, charts, for bar charts, pie charts, matrices, Venn diagrams, bubble chart, decision tree, radar chart, cycle diagram, flow chart, etc. So working with data frames. So according to Geek for Geeks or GFG, the Pandas data frame is a two-dimensional size mutable potentially heterogeneous tabular data structure with labeled axes, which are rows and columns. Data frame is a two-dimensional data structure. That is, data is aligned in a tabular fashion in rows and columns. And Pandas data frame consists of three principal components: the data, rows, and columns. So you can see an example of how the data will be represented in the data frame structure. So we have the columns, we have the rows, and we have the data within them represented accordingly. So few things about Pandas. It's a library within Python which allows us for data manipulation with integrated indexing. It's a tool for reading and writing data between in-memory data structures and different formats of CSV. CSV is basically comma separated values and text files. Then Microsoft Excel, SQL tables, and the fast HDF5 format. The intelligent data alignment and integrated handling of missing data gain automatic label-based alignment in computations and easily manipulate messy data into an orderly form. The flexible reshaping and pivoting of data sets. So before we move on further, what we are going to do is a majority of the session will be discussing an data set which is of IPL data set. IPL is basically an Indian Premier League which started in 2008, and on IPL's data set we will be discussing different things. So this is an information about the data set, uh, the name of the columns and stuff, and what are the data type and the description of what they mean. Starting with age. Age is done in a categorical manner. You can see that we have age category 1 as smaller than a player smaller than 25, then age category 2 for 25 to 35, and then age category 3 for greater than 35. Then runs S, run C, then highest score by the batsman, the average for batsman, the bowling average, strike rate, bowling strike rate, wickets, and so on. So now we will be shifting to Jupyter Notebook for the further carrying out the session further. So yeah, Pandas. So Pandas helps us. Pandas is a Python library which helps us in data manipulation of the data sets. We can import data and work around data for our use. So first we import the Pandas library as PD. We give it as an alias PD, else we have to write for the commands. We have to write the whole Pandas as name before we give the commands. So as you can see in the very next cell, we are giving an IPL auction DF data frame, and pd dot read CSV, which is a function of reading CSV file in Pandas, and this is the name of the data set. This is the name of the data set, and after passing this, we are able to read the name. Then we are here as the IPL auction. The IPL dataset contains many entries. So we are just displaying the first 5 entries here, and you can see the output if we run this run this, and how the output looks like. So here you can see that there are other columns between these age and auction year. After that, for printing the whole database, you can see we can do it like this, by print and auction IPL auction DF, and it will print the whole database. And you can also see the information about the database that we have, which is 130 rows and 26 columns. Now, to display the summary of the dataset, we can list and just give columns to the dataset, and it will list out all the columns that are present in the dataset, starting with serial number here till the sold price. Then transpose is some then other feature that it allows us, or the method it allows us, is that transpose. So transpose is basically moving rows to columns and columns to rows. So you can see the very data set was the columns have been moved into rows, and all the entries are in columns using the transpose. Next is size. As when we printed the whole data set, it also gave us the information about the size of the data set. But if you want to just see the size of it, you can do it this way with a dot shape, and it will just give you the size of it in a tuple format. And then dot info is another thing that is used to see how much memory has been being consumed by the data set. So you can see the data type objects here for different columns. We have int, object, then float and stuff. And in the end, you can see the memory usage here, which is 26.5 plus KB somewhere. So these are some of the operations. But now let's get to slicing and indexing of data frames. And just as we can slice and index arrays or a list, and arrays in other languages, list and list in Python and stuff. We can do it with DataFrame, and somewhat you can relate to the way it has been displayed. It can be used. So we have so from the start we have been using IPL auction DF, which we at the very beginning assigned it for reading the data set. Now we are making it to display the first 5 display the entries up to first 5 index starting from 0. So 0 is the starting point. Okay, so 0 is the starting point, and 5 is the ending point, but it won't allow a 5th entry. So here you can see the example of it. We are passing this, and it is displaying the values of it from 0 through 5, 0 through 4, and giving us the information of a number of columns and rows. Then if we want to select the last 5 records. We can use -5 instead of the starting point, and it will enter the dataset from the last, or it will start displaying the dataset from the last. And as we have given 5 here, it will display last 5 entries. Then there is another thing that we can do is select a particular column and display their entries. So here you can see that for our IPL auction DS data frame, we are selecting the column player name, and we are selecting up to 5 entries. So this is how it will display them. These are the 5 entries, and this is how they will be displayed. Next is a combination of one column and the other one, and displaying particular number of entries. So as we have decided to go with a player name and country, it will give us like the output like this. Next is ilog 49 and 4:9 and 1:4, which will basically start the 4 is the starting point and 9 is the ending point, and 9 won't be displayed. The same is for the column. This is 4:9 is for rows, 1:4 is for column. So it will select the first row, it will select the first column till the third column and won't include the fourth. So player name is the first, starting from 0, it is the first. So player name 1, then age 2, and country 3. As 4 won't be included, 4 won't be displayed over here. So you can, this is another way to display the records in the dataset. Then we have value counts and cross tabulations. Value counts provides the occurrences of each value, which is unique. And cross tabulation feature will help find occurrences of combination of values for 2 columns. So value count is for one single column, and it helps us to find unique values within them. So you can see that we are using it on auction DF for the country column, and using the value counts on them. So you can see here that we have 53 Indian players, 22 Australian players, South African 16 players, and so on. Then for let's say we do not want the actual values, but rather want the contribution of each country with its number of players. So this is how we can do it. We can pass in value counts, then normalize equals to true. So what will normalize equals to true will do is that it will count the number of players, let's say in India, and then it will divide it with the total number of players. So now after this, if we just multiply it with 100, we basically get the percentage. So that is what it's doing. So So that is what we are doing. We in the end multiplied it with 100 to get the percentage. So you can see here according to the countries and the and the contributions and that each country is making. So India has 40% of it, Australia has 16%, South Africa has 12% and stuff, and so on. So as you remember, when we discussed for this, just a second. For this, we discussed about the age being categorical, where we started with category 1, smaller than 25, then category 2 to 25 to 35, and category 3 to more than 35 of the age of the players. So this is basically the same thing displayed in a short manner. So what cross tabulation helps us is to work with two columns in one. So we will use pandas.crosstab or pd.crosstab, as we used pandas as a pd as an and pd as an alias to it. So crosstab age column of the df and the playing role column of the df. So you can see the relationship being displayed for the categorical age 1, 2, and 3, 25, 25 to 35, and more than 35. So you can see for age 1, we have 4 all-rounders, 5 batsmen, 7 bowlers, and 0 wicket keepers. For age 2, category 2, we have these numbers, and for category 3, we have these numbers. And you can see that age 2 or category of age 2 has most number of players being comprised in. Now after that, we will be discussing a bit about sorting data frames by column values. So sort values takes the column name based on which the records need to be sorted. So we'll be using IPL auction DF, and within that we'll use player name and their sold price, how much they are sold for, and sort the values of with the help of sold price, and then display the first 5 entries. So you can see that these are the players, and these are the values. So and also you can see that it is by default. As you can see here, we have not displayed anything. So by default, it is in ascending order. But if you want to change that, you can use the same whole command, and within the sort values, you can after the column name, you can put a comma. Ascending's value equals to false, and the same command will now be displaying the displaying the records in a descending order, where first we have Virendra Sehwag, then Yuvraj Singh, Virat Kohli, and stuff. So after that, if we are working with many entries, we can also find the need to create new columns. So we can create new columns by doing basic arithmetic with existing columns. So so this is the syntax to it in a way. The dataset df, the new columns name over here, the existing column 1 and the existing column 2. So the IPL auction DF, here we will set premium and the sold price minus the base price. So sold price is the price they were actually auctioned for, and the base price is where they started. And we are giving these arithmetic calculation being stored into a new column called premium. So for displaying this whole, will be using IPL auction DF. Then within them we'll be passing the necessary values, which are player name that we need to recognize the players, the base price they had, the sold price they had, and the premium, the difference of the sold price and base price. And we are only displaying the first 5. So you can see here, these are the people, players that for the start they and for the first 5 values, these are the players. So you can see what we did and what is being displayed. So the actual premium starts with uh, the the third record, or the second record index wise, which is a difference between sold price and base price. Now, if we want to display this similar to what we did before, if you want to display it in terms of in an ascending order, we will just simply have the command's ascending value to be false, and it will give us the highest to lowest. So here you can see that we have Virat Kohli, then Tiwari, then Yuvraj Singh, Tendulkar, and Sehwag. Then we then there is a group by function, which is used to display the ages connection with the sold price. What is the or which is the most relative to the age group or age category that we have created, and the sold price of the age category. So you can see that if we run this command, then it will be displayed in the series data structure format. So if we want to display it in a data frame manner, or within data frames way, so we can do that by assigning a variable first, and then using group by, and then in the end have a reset index, and that will be just a second. Yeah. So basically, what I wanted to say is, okay. Sorry, I shouldn't have run this cell, but so basically, what I wanted to say is that this output is being displayed in a series data structure. But if you want to change the way the output has been displayed, you can use it over here, and it will give the value in this format. If we print the sold price by age role separately. Then about joining data frames and taking multiple data frames and joining them into one. So this is this concept is a bit similar to what we do it in SQL for joining the tables and stuff. So and for that in pandas we use a merge, and this is the whole syntax to pd or pandas.merge, and we can uh, assign the desired values based on that. But for now, as we are comparing the sold price and sold price by age role that we just did over here, the sold price by age. And when we merge the sold price by age on them and have the outer join, how is the outer join over here? And within the syntax also, you can see how over here. Here it is given as inner, but we want the whole or both the columns to be included. So we'll be using the outer join over here. And if we display that, we'll get the output as this. And you can see that sold price is by default is given as underscore x or x, and sold price of the other one is or the other one or the right one. X is the left one, y is the right one, and that is being joined. So by default they are given these as the name. But if we want to change the name of these datasets, we sorry, not datasets but the columns, then we can do that by using the rename over here and uh, passing the values of the columns with the desired name. So you can see sold price X will be named as a sold price age by age role, and sold price Y will be given as a sold price age. Here you can also see in place equals to true. So what in place equals to true basically does is that it will change the changes that are being made by this command will be reflecting to the original at the original place also. All so these changes are not something a copy is made, a different copy is made, and then the names are assigned, but rather they are changed in the actual manner and everywhere. So this is why we are using in place equals to true. And if we decide to display this and use the first 5 values, then these are the output that we get. So for regarding the in place, as I mentioned, you can also read this when in place equals to true, the data is modified in place, which means it will return nothing and the data frame is now updated. When an in place equals to false, which is the default, then the operation is performed and it returns a copy of the object. You then need to save it to something. So separately, if we have it as false, and then we have to save it differently to another variable, as we have been saving different entries in different variables like that. Next, we have applying the operations to multiple columns. So as we have used premium, this premium is change. We will call it change over here, and this will be the formula that will be assigned. That will be applying this formula to different or multiple columns. So average sold price for all the players in the age and the playing role category minus the average sold price for all the players in an age category divided by the average sold price for all players in an age category. So for sold price comparison, the change is the new uh, column that will be uh, assigning these calculations or these entries in saving these entries into. So we'll be using the apply function and then use lambda function or the anonymous function of the Python to uh, carry out the to define the expression of the formula that is being displayed above. So this is the formula, and which is being which is the expression of it, and then after that we'll be displaying the result. So yeah, this is the result. So here you can see that we have the last value is x is equals to 1. So in pandas, the x is 0 refers to rows and x is 1 refers to the columns. So as we want our operation to happen in column, that is the reason we have given x is equals to 1. Then filtering records based on conditions. So if we want to see the most number of sixes being hit by a player and get the record of the player's name and the number of sixes that particular player has hit. So we can do it with uh, the first condition displayed within the square brackets. So the first is the first column of the uh, IPL auction DF is being greater than 80, and then in other we uh, display the name of the players and the number of sixes. So after running this, we'll get this output. So you can see for index number 26, I guess, we have Chris Gale for 129 sixes being hit, then Adam Gilchrist, and for 86 sixes and stuff. For removing a column or a row from the dataset, so we just saw of adding the column. Now we'll discuss about removing a column or dropping a column from the row or a row from the dataset. So to drop a column, pass the column name and access as 1 for column, and to drop a row, pass the row index and the access as 0. As we just mentioned over here, for 0 for rows and 1 for columns. And this is the same kind of this is going to use the same thing. So we'll use for dropping, so we'll use a drop method on serial number. If you remember that the first time we displayed the whole data set, we had a number called serial number. So this serial number is not, we don't want it, and we want to drop it. So this is what we are doing by dropping down that column. So, about the in place that we just discussed about, we do it or we make the changes in the whole data set because we want to avoid making new data frames for each and every operations that we want, because having more data frames also consumes memory. So regarding the removing the continuing with the removing of column or row, we as mentioned that we will be dropping the serial number column in place equals to true, and because it's a column, we will pass x is equals to 1. And you can see when we display the columns of auction df, you can see we no longer have sequel serial number in the list. Next is matplotlib. So matplotlib is another Python library that helps us in representing the data and in a visual manner. So matplotlib is a comprehensive library for creating static, animated, and interactive visualizations in Python. So with matplotlib, as just mentioned over here, we will also be using Seaborn, which is data visualization library based on matplotlib. So just as for pandas, we gave an alias PD. For matplotlib, we'll be using PLT, and for Seaborn, we'll be using SN. So first way of representation of the data is going to be bar plot or bar. So these are nothing but the bar charts. So to display the average sold price by each age category, we pass the sold price as a y parameter and age as the x parameter. So Sn for Seaborn, bar plot, its function, and within that, if we use x for age and y for sold price, and the data through sold price by age, then we will get this bar plot. You can see the age category 1 has the most for the sold price. So for average sold price, each age category but grouped by a third variable, that is playing roles. So the parameter hue takes a third variable as parameter. In this case, we pass a playing role as a hue parameter. So for another way of displaying the data is that cbound dot bar plot, and giving the age by their values, we'll be using hue for a playing role. Then data equals to sold price comparison. So you can see the comparison that are being made with respect to different playing roles. for the age as well as the sold price age role. And for that, you can also see that age group of 1 for the batsman is highest. But as for the all-rounders in the age category 3, we have more all-rounders over here. The next data representation manner is a histogram. So histogram is a plot that shows frequency distribution of a set of continuous variables, and we will draw a histogram, invoke hist method of a matplotlib library for sold price from our dataset. So PLT for matplotlib hist, its hist function or histogram function, and we'll use it for sold price. So this is the output that you will get for it. So as you can see that we have only passed sold price as the input over here, and by default it is of 10 bins. What is bins? Bins are the these so every get and these vertical bars are called bins. So by default these are these are of 10 of value, but if you want it to be more or less, you can assign it through this. So here, as you can see, it's the main it's the same command, but bins being equals to 20. So you can see for bin value of 20, you will get the histogram that looks something like this for the data set that we are doing. Next is a distribution or density plot. So the dist plot represents. So you just make sure that the dist plot that is being used here. I've also mentioned it over here, but the dist plot is being changed by the Seaborn to dist plot. So you just have to remove the first D from the dist plot before using it. So the dist plot represents the univariate distribution of data. That is the data distribution of a variable against the density distribution. So the Seaborn dist plot function accepts the data variable as an argument and returns the plot with the density distribution. So the distribution of a density plot depicts the distribution of data over a continuous interval. Density plot is like smoothed histogram and visualizes distribution of data over a continuous interval. So a density plot also gives insight into what might be the distribution of the population. So if we use the dist plot over the sold price, you can see this is the output that we will get for the data set that we have. Next is a box plot or box and whisker plots, which shows the distribution of quantitative data in a way that facilitates comparisons between variables or across levels of a categorical data. So a normal box plot syntax is like this. You can uh, you can change the values depending on what kind of output you are looking for. The parameters here is a feature x as feature of dataset, y is a feature of dataset. Okay. Then hue for a feature of dataset and data. Okay. So a graphical representation of numerical data that can be used to understand the variability of the data and the existence of outliers. So box plot is designed by identifying following descriptive statistics, which is lower quartile, first quartile, median, and upper quartile. Then lowest and highest values and interquartile range (IQR). So we'll be using box plot, first assigning it box and then assigning it to box and then displaying it. So this is what the box plot for sold price looks like. And these are the outliers that we have over here. So if you want to, this is it. Yeah, this, as you can see, we have given it for its x value being equals to this. So that is the reason it is being displayed in a horizontal manner. But but if you just don't give it or don't assign it to any of the value, it will be by default like this. So box plot returns details of box plot in a variable box. So the caps key in box variable returns the min and max values of the distribution. So you can see the min and the max values over here. So if you want a numerical value for these box plot items, you can pass on this get y data for start for the item in box and caps. Then you can get these value here. The you can see the minimum auction price offered and the maximum price that was offered as the output. Then for interquartile range, the median key in the box variable returns the median value of the distribution. Here the median value is 43750, and for getting that you can pass this in order to get the value. And similar for the whiskers, you can also get y data, and for each item in it you can get the value over here. So for displaying some of the outliers as it was displayed over here or here, uh, will for the sold price, you can see that sold price being greater than 13 lakh. You can see the player name, player role, and sold price being displayed for the comparison being made. So if we pass this command, and then it will give us these values, and you can see MS Dhoni being at the top, then we have Andrew Flintoff, then Virat Kohli, and so on. Then in the end, sorry, not the end, but now starting with the comparing distributions. Or comparing different distributions by overlapping them. So there are some distributions that you want to keep them or overlap them in order to get the insights that you want to see. Rather than comparing them side by side, you actually overlap them in order to get the insight. So that is what we are going to do here for the captaincy experience of the players and how their sold price affect for the captaincy experience. So if a player has an captaincy experience, if it has, it will be as you can see, it is assigned as 1. And if the player does not have a captaincy experience, it is assigned as 0. So, and what we are comparing is that a captaincy experience affecting the sold price or not. So if we run this hold command or the whole snippet, then it will show us this graph, and you can see the captaincy experience and no captaincy experience has not a clear way to be showed for the so so the sold price with or without a captaincy experience has been displayed. So it can be observed that players with a captaincy experience seems to be paid higher, and now some kind of same kind of distributions can be compared using box plots to visualize sold price for each playing role, and then passing the playing role, which are playing role as a x parameter and sold price as y parameter on the box plot method of cpawn. So you can see for the playing roles and for the sold price, you can see the relationship between them, the minimum and the maximum values, as well as the outliers. And this is a command which does that, by the way. So a few observations from the box plot that is displayed above. The median sold price for all-rounders and the batsmen are higher than the bowlers and the wicket keepers. And the all-rounders who are paid more than 135 uh, 135,000 USD or are not considered outliers. All all-rounders have a relatively high variance, and there are outliers in batsman and wicket keeper category. You can see the outliers that were displayed over here. So we have already found that MS Dhoni is an outlier in the wicket keeper category. Then scatter plot, which is another way of representation of the data points. So here the data points will be represented. Here the data points will for each and every data points there will be a representation. So it needs two arrays of the same length, one for the values of the x-axis and one for the values of the y-axis. The you can see the displaying the scatter plot for the playing role and the batsman, and we are using the scatter plot for for the number of sixes and the sold price. So basically what we are trying to do is check whether the number of sixes hit by a player in the past can affect the sold price of that particular player in the present or not. So you can see the data points being plotted into the space. Now, if we want to find a correlation between these values, we can use something in cpawn called as a rich plot, where we can give x-axis to uh, uh, sixers and the sold price to the y-axis, and the data the IPL batsman DF. Something that we did over here also, and align them with the rich plot method. And you can see for the same plot that was being displayed before, we have a line to fit, or a line which displays the correlation between them, a straight line. This is the same plot that is being used, but in rich plot, so that we can find the correlation of the number of sexes and the sold price of them. And yes, there is. So the number of sexes do affect the price of the player. Moving further with a pair plot. So if there are many variables, it is not convenient to draw scatter plots for each pair of variables to understand the relationships. So a pair of plot can be used to depict the relationships in a single diagram, which can be plotted using pair plot method. So we'll explore the relationship of four variables: uh, strike rate of batsman, average, sixes, sold price, which we think may be the influential features in determining the sold price of the batsman. And these are some of the these three are some of the uh, statistics of the batsman which can affect the sold price. So using these three, we will be choosing whether the sold price of the batsman is affected or not, or how it is influenced. So for influence features equals to taking the uh, in the columns or the features of the data set and including these. Then we use the pair plot on them. So okay, I hope you can see the uh, whole pair plot being visible on the screen with the uh, uh, given values or the given features that we included. Next is a correlation and heat map. So correlation can also be stated as a directly and inversely proportional relationships, or it has a statistical measure that indicates the extent to which one variable changes together. A positive correlation means the variable increases or decreases together, means being directly proportional, and a negative correlation means if one variable increases, the other decreases, inversely proportional. So the correlation value lies between -1 to 1, and the sign indicates whether it is positive or negative correlation. The negative one indicates a perfect negative correlation, whereas a positive one or +1 indicates the perfect positive correlation. So for finding the correlation, all we have to do is this with the influential features that we just discussed before, and use a correlation on them. And you can see the correlation that are happening. And also do make sure that this is like a matrix, as there are correlations being made with the same features. So it is diagonally being divided. So this is for correlation. Next is a heat map. So uh, so this is what the heat map would look like if we represent them in the same manner as we did for correlation. These are the same values. So these are the same values being displayed in terms of heat map, and you can see it is being diagonally divided. So setting anot attribute to the true prints the correlation values in each box of the heat map and improves the readability of the heat map. This, and here the heat map shows that the average and the sixer show positive correlation, while sold price and strike rate of batsmen are not so strongly correlated. So sold price and yeah, you can see it's a 0.1 value year and year, that they are not sold price and strike rate of the batsman is not being strongly correlated, whereas average and sixers are 4.7 of its value. Next is handling missing values. So and so you can see so what we started discussion is for the data sets which are well structured and does not contain any of the missing values, but that is not true in many of the data sets if we start collecting the data and stuff. So how how do we manage or handle the missing values? So for this, we will be using a different data set, which is not related to IPL, but rather the uh, uh, whether for the different cars and their characteristics. So the data set that we are going to use are auto mpg.data, the separate the giving the separating values and the header as none. After that, we'll be displaying the top 5 or the first 5 in the data set. First 5 values of the data set. You can see that as we are giving header equals to none, it will not be giving any of the names. But because we want to give our own names, so you can see for the auto columns, autos autos dot columns, we will be giving the columns our own names, and then we'll be displaying the entries again. So these are the names that we'll be using: cylinders, displacement, horsepowers, and stuff. Or in a way, you can say that it's a spec sheet of different vehicles or cars, to be particular. So you can see that the now if after giving the names, we are uh, we are getting the names of the columns over here that we have given. Then we check the autos.info for the memory consumption, and you can see 28.1 plus KB. We are trying to change the horsepower's number. Okay. The horsepower's number, which is a non-numeric data type, into a numeric data type. And for that, we can use a two-numeric method and passing horsepower in it, the errors coerce, which will be explaining further. And with that, we'll be able to convert a non-numeric data type into numeric data type. So you can see the errors that was given here, assigned here was coerce. So we have three choices for errors, which is ignore, raise, and coerce. And by default, it's raise. So if raise, then invalid parsing will raise an exception. Coerce, the invalid parsing will be set as a nan or not a number. Then invalid parsing for ignore, we invalid parsing will return the input. So error equals to coerce. That what we did is used to handle errors while converting to numeric. So it converts problematic entries to not a number values. And autos.info is used to display the information about the data frame autos after performing the conversion. So you can see the from object, it's converted into float, and we have the same memory, almost same kind of the memory consumption. Now check for checking the null values in a particular column. Here we will use it on a horsepower in the autos dataset, and pass on the is null to check whether it contains any null values or not. And if we run this, it will give this output. And these are the values. These are the values that will contain the null values or the missing values. So using drop drop any rows of data frames can be dropped, and drop any method removes all rows with nan values. And here horsepower is the only column in the data set to contain those missing values. So we'll drop these values which contain these nan values, and using the drop.na method. So this is how you give it pass the values. So for subset equals to horsepower, and then uh, again check. And if we check it after after passing these values or dropping the nan values, you can see that there are no rows to be displayed or no data to be displayed. So yeah, this is for the descriptive analysis. This is for the descriptive analysis that we used for on the IPL dataset as well as the autos dataset for dealing with the missing values. And yeah, thanks for listening. There will be different references that will be updated in the different sessions, and also when the video will be posted, the relative references will be given. Yeah, thanks a lot for listening.
Hey, excellent job, Jamit. It covered very extensively from the lesson we started at the beginning, and there is a connection between what was there in the lesson and the coding that you showed. So hopefully
Yeah,
we will have questions and feedbacks once we post it. At this time, the recording looks good to me and good to go. So I will just post it once we have it ready, and we can go to the next lesson on Monday. Right? There is
yeah.
nothing on Saturday this time, I hope.
No,
Okay. So we go to the Monday session. Saturday, if you have anything, we can discuss over the call. Okay.
sure.
So I'll stop the